In this module, we are going to solve a sum based on finding the area of a shaded portion. Here is the question which says, quadrilateral ABCD is a trapezium with AB parallel to DC as shown in the figure. And the value of angle BCD is 60 degrees as you can see over here. And BFEC is a sector. And the center of the sector is C. The values of AB and BC are 7 centimeters each. The value of DE is equal to 4 centimeters. We are supposed to find the area of this shaded region. If you observe, the shaded region is a part of a trapezium. So we write the area of the shaded region is equal to area of the entire quadrilateral ABCD, and from this we are going to subtract the area of the sector. So we have minus area of the sector C dash BFE. Now students, tell me what is the formula to find the area of a trapezium? Yes, it is equal to half into sum of parallel sides into height. Now here the parallel sides are AB and DE. So we have the area of this trapezium as 1 upon 2 into AB plus DC into the height. As the height is not mentioned, let us construct it. For that, we are going to drop a perpendicular, that is BL perpendicular to DC. So here BL becomes the height. Students, the value of AB is already given in the question, which is 7 centimeters. But we don't know the values of DC and BL. So let us find them. For DC, observe certain things in the question, in the figure itself. If you observe BC and EC, what can we say about them? Yes, they are the radii of the given sector. And we know that the radii of the sector are equal. So we can also write BC is equal to EC is equal to 7 centimeters each. Further, if you clearly observe DC, it is made up of two parts. One is DE and the other is EC. So we have DC is equal to DE plus EC. Let us substitute their values. The value of DE is equal to 4 centimeters and the value of EC is equal to 7 centimeters. So the value of DC will be equal to 11 centimeters. Now students, we have found the value of DC. So let us focus for BL. For that, we are going to consider a triangle, that is triangle BLC. In this triangle BLC, observe the angle BCL. Now for this angle, we have certain observations. The opposite side of this angle BCL is BL and the hypotenuse of this triangle is BC. So students, tell me, with this ratio of opposite side and hypotenuse reminds us of, yes, it is the trigonometric sine ratio. So we can write in the triangle BLC, sine 60 will be equal to opposite side upon hypotenuse, which is equal to BL upon BC. The value of sine 60 is root 3 upon 2 is equal to BL, which we are finding, upon BC, which is 7. On cross multiplication, we get the value of BL is equal to 7 root 3 upon 2. Now students, we have also calculated the second part. So now we need to calculate the area of the quadrilateral ABCD, which is equal to half into AB plus DC into the height, that is BL. Let us substitute the values. So area is equal to half into AB, that is 7 plus DC, which is equal to 11, into BL, which we found to be 7 root 3 upon 2. This is equal to half into 18 into 7 root 3 upon 2. 2 into 1 times is 2 and 2 into 9 times is 18. Further, we can write it as 9 into 7 root 3 upon 2. Now students, we get the area of the quadrilateral ABCD is equal to 63 root 3 upon 2 centimeters square. Now students, let us focus on finding the area of the sector. So tell me, what is the formula to find its area? Yes, it is theta upon 360 into pi r square. So we write area of the sector C dash BFE is equal to theta upon 360 into pi r square. On substituting the values, we have theta as 60 degrees upon 360 into the value of pi is given to be 22 upon 7 into r square, which is nothing but 7 into 7. On further simplification, 0 terms get cancelled. 6 into 1 is 6. 6 into 6 is 36. 2 into 3 is 6. 2 into 11 is 22. 7 terms get cancelled. So we are left with 11 into 7 upon 3, which is equal to 77 upon 3 centimeter square. Now students, we have calculated the area of the sector as well. Now we can find the area of shaded region, which is equal to area of the trapezium ABCD minus area of the sector, that is C dash BFE. On substituting the values, we have area of the trapezium, which was equal to 63 root 3 upon 2 minus 77 upon 3. Let us substitute the value of root 3. This is equal to 63 into 1.73 upon 2 minus 77 upon 3. We have 2 into 1 times as 2 and 2 into 31.5 times as 63. Further, we can also say 3 into 1 is 3 and 3 into 25.666 as 77. So we are left with 31.5 into 1.732 minus 25.666. The product of the two terms is 54.558 minus 25.666, which is now equal to 28.89 centimeter square. So the area of the shaded region is 28.89 centimeter square. Thank you.